All right, you can
Good
start. Yep, good to go.
Good. Good morning, everybody. I'm Sam Stosky. I'm the project manager for Primus Locus Engineering. With me today is a team of engineers working alongside me for the County Road 38 reconstruction project. So today we're going to be going over the final alternatives selected within each engineering discipline, as well as the analysis behind that selection. So to recap from the previous presentation, some of the main goals for this project are to redesign the existing roadway to plan for future growth within the area, as well as implement a new visitor center to promote visitor and community engagement. Some of the major impacts from this will be increased employment opportunities, whether that be for those inside or outside the community. There will also be improved mobility along County Road 38 for traffic on the new roadway, as well as pedestrians traveling on the sidewalk or bike path. And lastly, there will be environmental consideration, which will provide many benefits for the well-being of the community. And attached here is the deliverables up to date so far, showing some of the progress we've completed, as well as the last deadline for phase 1, which will be the design binder for each engineer. So for choosing the final alternative, each engineer will design or construct a weighted rubric. This rubric will have specific criteria relative to their discipline. These criteria will then have weights based on their importance. Using this rubric, the engineers will rate all of their alternatives, showing the comparisons within them. Once they are rated, the engineers will be able to pick the optimal alternative for the final design. After all the alternatives are chosen, we were able to construct a design and construction cost estimate. This will be talked about later in the presentation. So as well as being the project manager, I am the water resources engineer. Recapping some of the things from the previous presentation, my main goal of the project is to treat the water quality volume from the impervious areas to improve water quality while also reducing the phosphorus load by at least 65%. I will also be designing systems to store the flood control volume within the project. All of these designs will be done in accordance with the local, state, and federal regulations. In the previous presentation, I also ran through the steps and calculations to calculate the water quality and flood control volume. For the sake of time, I will not recap those, but they are attached in the technical memo. I also presented 3 alternatives in the previous presentation. I did add a 4th for the analysis and picking the final alternative. So recapping the major components, alternative 1 had the bioswales on the north and south end of the road. The visitor center had the storm sewer system leading to the infiltration basin. On the east side, it was the curb and gutter system, and alternative 1 had the hydrodynamic separator leading to rain gardens. Alternative 2 was the same bioswales on the north and south end of the road. However, this time at the visitor center, instead of the storm sewer system, it was the rain garden leading to a detention basin. And then on the east end of the road, it was the catch basins again and a curb and gutter system. However, without the hydrodynamic separator, it was now rain gardens, then leading to underground infiltration storage. Alternative 3 changed bioswales to roadside ditches on the north and south end of the road. It then went back to the storm sewer system at the visitor center. However, instead of all of the water being concentrated from the visitor center into that system, only the east end of the parking lot would go into that system, and the water running off from the north end would go into the roadside ditch. The east side was the same as alternative 2, with the rain gardens going into the underground infiltration storage. So alternative 4 was the new alternative. This one was the permeable pavement alternative. So as you can see here, I added permeable pavement at the visitor center and permeable pavement on the road on the east end of the bridge. I did this based off some of the feedback from the progress presentation. I wanted to make sure that this was included in the analysis to see if it was a viable option and how it compared to the other alternatives. So for the weighted rubric of this analysis, starting with the top, I made cost my most important criteria with a weight of 3. This for me was the most important because after finding the water quality and flood control volume, I was able to apply it to the systems within the alternative. And I knew that I would be able to treat and contain the water. So for me, it was a matter of how cost efficient can I be to do that. Moving on to the next three, these are the three main points of my scope: treating the water quality, having the phosphorus removal, and containing the flood control volume. These all then had a weight of 2. Next is the land footprint. This has a weight of 1.5. This was important for me, especially around the developed areas with communities. I did not want to include systems that would disrupt those communities or cause problems in the future. Last was aesthetics with a weight of 1. This wasn't incredibly important to me because most of my systems can't change too much with the aesthetics. However, for systems being put in around the visitor center, I wanted to make sure it was visually appealing since it will be a brand new center. So this is the complete ranking of each alternative. So for my final alternative, I decided to pick and choose the best systems within each alternative to make a whole new final alternative instead of just choosing one solid alternative. So the green will represent systems that were selected, and the red will represent the ones that were not selected. So a sample plot to help understand this table, starting with bioswale at the top, I would rank each criteria on a scale of 1 to 10, and then based on the multiplication of the weight, I rated this a 7, which then went to 21. Adding the columns of each criteria, we would get a total. So for the bioswales, it was a total of 81.5 versus, let's say, the roadside ditch was 75.5. Therefore, I went with the bioswales. And then separated each system within its own jurisdiction. So the water quality volume systems were separated, and then the flood control volume systems were separated. And then here are the impervious area systems where the systems are used either at the visitor center or on the east side of the bridge. So using all of those selected systems on the previous slide, I was able to construct the layout of the final alternative. So here is the bioswales on the north and south end of the road, leading from west to east, passing through the culverts, finally going to the rain garden with an under drain going into the infiltration basin. At the visitor center, I did go with the storm sewer system. There will be grass strips in the parking lot to allow pre-treatment for the water collecting in there, going to the detention basin. I also did follow alternative 2 and put the rain gardens on both ends of the parking lot to allow extra treatment for water running off into the basin. On the east side of the road, I went with the curb and gutter system leading to the rain gardens. These rain gardens will be supported through barrier walls to ensure they remain structurally intact in the case of strong flow, and then these will filter down into an underground infiltration storage. So with my final alternative, in the future I plan to minimize costs within each system while also improving the efficiency, coordinating with each member of the team to do so. Thank you very much. I'll now pass the mic to Sim.
Thank you, Sam. I'm Simeon, and I'm the environmental engineer with PLE. So the project objectives for the environmental engineering component of the County Road 38 reconstruction include designing complete clean water treatment that requires meeting the most stringent EPA drinking water standards by using the latest treatment technologies. Additionally, the project demand was forecasted for the next 25 years, which requires 1 million gallons per day of clean water to be supplied. To recap my alternatives, the first alternative was the type of water source. Surface water is the first type, and it would be extracted from the Elkhart River, as shown on the bottom right of the figure. The second option was groundwater, which would be pumped from wells, shown on the left side of the figure. And the third option was using the existing network, which would be connected to just east of the Elkhart River, which isn't shown on here, but the pipe network to connect it to the visitor center is. The location of the surface water and groundwater was coordinated with the other team members, and the existing water network was eliminated due to concerns in its ability to supply the 1 million gallons per day. The second alternative revolved around the treatment components. The first type would be the flocculation basin. There can be a vertical turbine mixer, a paddle flocculator, or a baffle channel. The vertical turbine mixer is a confined unit, while the paddle flocculator is slightly bigger with better water quality. The baffle channel was eliminated due to it being a more old technology that does not meet the criteria of recent technology. And the type of sedimentation basins considered were a rectangular clarifier and a circular clarifier, once again having differences in size and water quality. The third alternative was the water distribution. The type of water storage was evaluated for this alternative. The three possible types of water storage were ground level storage, below level storage, and hydropneumatic tank. The ground level storage and below level storage would house around 500,000 gallons, while the hydropneumatic tank would not be able to supply that much. Thus, it was eliminated before more in-depth alternative analysis occurred. And the three are shown on the left side of this figure. The alternative criteria was evaluated using the parameters of water quality, cost, operation and maintenance, land footprint, and aesthetics. Water quality and cost were of the utmost importance, thus being factored with a multiplier of ×3, because water quality is imperative to the health and safety of the citizens of Goshen, while cost is also extremely important in providing a cost-effective design for the city of Goshen. Operation and maintenance was also weighted with a factor of 2, because the standard level of labor is a characteristic that will last the life of the water treatment plant. Land footprint measured the amount of land consumed by each alternative, and aesthetics measured the visible obstruction from each alternative. So, using the same alternative scoring system that Sam described, surface water was selected due to its superior water quality. The vertical turbine mixing was selected due to its reduced cost and confined space. The sedimentation basin selected was a circular clarifier due to its superior water quality attributes. And finally, ground level storage was selected due to its far reduced cost compared to a below level storage. So the selected alternative is displayed here. The bottom right indicates the location of the surface water treatment, and a pumping and piping network is required to transport that treated water to the visitor center. And finally, the more in-depth schematic of the water treatment includes a water intake located in the Elkhart River, which transports water to the rapid flash mixing. This flash mixing is then, the water is then directed to the vertical turbine flocculation basin selected. It is then settled in the circular clarifiers that were selected before going to the rapid sand filtration unit. It then ultimately gets to the disinfection station before being stored in a ground level water storage unit. Thank you. Here's Mateo.
Thank you, Sim. My name is Mateo Duran, and I'm the lead of the structural department for PLE, and I'll be talking to you about the visitor center that PLE was tasked with designing for the County Road 38 corridor project. So, to go over the objectives as we did on the last presentation, PLE was tasked with designing a visitor center to service various populations, such as the motorists or drivers going through along County Road 38, going through Goshen, and even the general population of Goshen or around the visitor center who are looking for just something to do, somewhere to visit. The project requirements were we needed to have a 2-story building with 40,000 square feet of indoor space and 1,500 square feet of covered outdoor space. So with that, we created this, which is the general construction for all of the alternatives that we will be showing later on. Shown right now is alternative 2, where we have masonry walls, steel beams, and timber roof joists for the upstairs level. And all of our buildings will be following this layout, just having different materials for each alternative. So this is the general layout. We have 41,800 square feet altogether, with 32,000 square feet being on the first floor, where you walk into a lobby, then you have a gift shop, a museum, and we also have an area for Elkhart County to have their maintenance run out of. Then on the second floor, we have another 9,000 square feet of covered space for a restaurant, which leads out to a patio, where we also have a green roof and a garden and more covered space. And all in all, we will have 3,450 square feet of covered space outdoor. So, alternative one included a fully steel frame structure, and this alternative came out to be around $9.5 million. This would be steel framed on both the first and second floor with the tapered steel columns, as you can see here, on both sides. Steel beams going across the top, which are supported by these interior columns. And then we would have steel paneling, which would be insulated to allow for energy savings when it came to heating and cooling during the winter and the summer, respectively. Alternative two, which was shown in the first photo, would include the masonry walls all the way around with steel beams and the steel columns in the middle, as well as a timber roof joist for the second floor on the restaurant. This came at a total cost of about $9.4 million. And as you can see, the first floor, we would have those masonry walls, steel beams going across with the unbraced length carried by these interior steel columns. And then we would have composite decking running along those beams in order to create a nice base for our second floor, which will then be carried by masonry walls and also have timber roof joists upstairs in the restaurant for that aesthetics for people that are dining there. And those would be covered by steel panel roofing, which again would be insulated to help with energy savings. And then alternative three is very similar to alternative two, with the difference of having steel joists instead of steel beams running along the top of the first floor. This came at a total cost of $9.1 million. Once again, masonry walls all around, steel columns to support unbraced lengths, steel joists instead of the steel beams and composite decking on top. And the second floor, we would have the same masonry walls with the timber roof joist for aesthetic and steel panel roofing. So, with these alternatives, I created a ranking criteria with cost and factor of safety being the top parameters needed to be met. As engineers, we are supposed to ensure the safety of the public, as well as make sure we have a cost-efficient design at hand. And I also had environmental impacts, workability, and aesthetics as well, with environmental impact and workability being a factor of 2 and aesthetics a factor of 1. I also ranked these from 0 to 10, with 0 being unacceptable, to 10 being the most excellent. With this, you can see how I was able to come to a conclusion on what materials to choose. So for the floor, we ranked the steel beams with the steel joist, with steel joist winning out just barely when it came to the workability as well as the aesthetics of the joist. And then for the restaurant roof, we had the option of timber trusses or steel trusses. And once again, timber trusses come out, especially when it came to the workability and aesthetics that the timber provides, especially if you're there eating. Sometimes you like to have something nice to look at. And for the exterior walls, we had masonry and the steel columns with the paneling all around, where the masonry came out especially for the aesthetics and for the cost, because the masonry is more readily available around here than the steel columns would be. And with that, I selected alternative 3, which was the masonry walls with the steel joist and the timber roof joist for the second floor restaurant. First and foremost, this provided an easier construction. The masonry walls don't have to come all in perfect pieces like the steel columns would have to, as well as the steel joists. They can be broken apart and fixed if there are any issues with them, and the erection is a little bit easier when it came to the steel joist. It is cost effective as well, with the masonry being a little bit cheaper than the steel columns, steel joist being a little bit cheaper than the steel beams, and the timber roof being cheaper than the steel roof. And it would be aesthetically pleasing, which would allow for an inviting place for people to want to go into, rather than somewhere that might be a little bit uglier and might deter people from coming and visiting. Thank you, and now I'm going to pass it over to Vince.
Thank you, Ted. So these are my objectives for this project. So the first one is to design an effective intersection which provides an appropriate level of service. I also plan to account for heavy vehicle traffic like semi-trucks, as that's an important part of, I guess, the new intersection design. And I also plan to design a parking lot for safety and spacing also for the new visitor center, to make sure that people have an appropriate means of visiting. and having enough space and everything. And I also plan to ensure pedestrian and bikers are safe when crossing the intersection, especially with the new development coming into play. So the first alternative I have is a signalized intersection with crossing on the south end of the site. This is a signalized intersection with 4 approaches. There's allocated turn movement lanes. This is the most controlled intersection and is also safer for pedestrians and bikers, which is an important aspect of this project. And this is the alignment on the west side of the project, and as you can see, we have the 2 lanes for the left turn and through, and also the entering and exiting out the visitor center. And in the blue is the proposed multi-use path with the brown being the roadway. And here we have our alignment east of the intersection, and this is the right turn through and left turn lane, and with the multi-use path on the south end, in the blue also. And this is the alternative at the underpass for the County Road 38, because there's already currently existing, pedestrian means of transport on the north end of the bridge. And this is basically just showing that we're going to connect the new multi-use path with the underpass currently existing at the bridge, or with the pedestrian modes of transport existing on the other side near the bridge. And this is the second alternative, which is a roundabout intersection with crossing on the south end. This is quite similar to the other alternative, but it is a roundabout with 4 different approaches, north and south on County Road 21, and also east and west on County Road 38. And this would have the path on the south side, as mentioned before. And this is the alignment. As you can see, it's pretty much the same as the previous one, except we have the center circle in the middle. And we have a through and left turn and right turn lane. And this is also the same thing as pretty much the other side, the other alternative with the underpass. And this is alternative 3, which is a roundabout with crossing on both ends of the roadway. This would be a roundabout also, which is similar to the last one, and would have path access on both the north and south side of County Road 38. And as you can see here, we have the roundabout, or we have the multi-use path crossing the roadway and going north a bit, and then crossing on the north side of the intersection that was designed. And we have that continuing on, basically all the way to the subdivision, which is about right over here, and we dropped it down a bit because it makes more sense to connect it with the existing path currently on that side of the roadway. And this is showing it connecting with the proposed path on the south side with the path on the north side. And this is the criteria that I use for alternative evaluation. So I rank things based on high, medium, and low priority. Nothing I chose fell into the low priority category, but stuff that fell in the high was environmental concerns, cost effectiveness, land use, safe pedestrian and biker access, and level of service. Medium priority was construction difficulty, time to complete, and aesthetics, with things like, I would say, pedestrian and biker access that had the highest, I believe, out of all of these. And this is the scale that I use to measure these. So pedestrian and biker safety, we decided to have access. Pedestrians and bikers need to have, do not need to use the roadway. There needs to be plenty of spacing between pedestrians and bikers, and no risk of being hit by a vehicle, at all, pretty much. And this is how I got the total ranking. I did the weight times basically the rating that was given to the alternative, which was shown up here. It's at the very top. So pedestrian and biker safety, I can use that as an example. So basically we used a ranking of 9 for pedestrian and biker safety, and its weight, as shown here, was a 10, I believe. 10 times 9 is 90, so that gives us the 90 for the pedestrian and biker safety total. I did the same exact thing for each of the other columns, and whichever one had the highest total number of rankings was the one that was decided to be utilized for the alternative selection. And at the end of the day, this is the one that wins out, the signalized intersection crossing on the south end of the intersection. It meets categories like pedestrian and biker safety, cost effectiveness, land use, and also like aesthetics. And now I'm going to hand it over to Sam to do the cost calculations.
Thanks, Vance. So as I stated earlier in the presentation, once we got the final alternatives selected, we were able to calculate the design and construction costs for each alternative and the project as a whole. So our PLE completed a work breakdown structure that highlighted the amount of hours for each engineer to work on the design work. That is attached in report 2. So the hours are shown here, then taking the billing rate and adding them all up, it was about a total of $88,000 for the total design work of this project. Moving on to the construction costs, knowing the final alternatives selected for each engineer, we also knew the components within them. So using sources such as RS means or other sources also referenced in report 2, we were able to complete a construction calculation for each engineer, adding them all up to get a total of $20.6 million. Thank you very much. Any questions? Question? Oh, sorry.
Yes, I have a couple questions, I guess. So going back to, I guess, the environmental side first. In the matrix, you have, you're evaluating water quality and cost. And I would say, is there a close connection to those? Because any system you design meet the standards, like the EPA standards?
Absolutely. I think every source for going to the criteria matrix right here, there is a correlation because it costs more to do extensive water treatment. So when the designing was occurring relative to surface water or groundwater, each part was pretty much designed to meet the EPA standards, and groundwater and surface water in specific would both meet the most stringent EPA drinking water standards. There were just concerns with groundwater in particular with the water source having heavy metals such as arsenic. It wasn't enough to mount concern necessarily over the contaminants that would be found after the water was treated, but there still is an elevated risk because of that. So that was taken into account for the water quality. But generally speaking, for the rest of the alternatives, there is a trade-off between water quality and cost. So a lot of the tiebreakers, if you will, came through the other criteria, such as operation and maintenance and the amount of land consumed.
Mm-hmm. Yeah, is there, I would say like with water quality, is part of that difference in rating because maybe the standards for certain heavy metals aren't still ideal, right? They still put maybe the public at risk if they're exposed to those.
Absolutely, yeah. That was taken into the water source and the treated water were taken into the contaminants found anywhere in the treatment. So I guess the better description of this would maybe be not just the treated water, but the water process in general, because if there is heavy metals found anywhere in the treatment process, that proposes an elevated risk for residents and the workers operating.
Mm-hmm. All right, thank you.
Thank
That's
you.
good. And then I guess the only other question was on the water side, Sam. So you ruled out permeable pavement.
Yeah.
Can you go back over that just a little bit?
For the rate, yeah. So looking at all the other options versus permeable pavement in that impervious section that I listed as the visitor center and the east side of the bridge, permeable pavement was like the most expensive for those options, along with the hydrodynamic separator, but permeable pavement had a lot of constraints going into it, like on how to construct it and coordination with other engineers. So I thought basically for that most important column of like the cost and everything, it was easiest to go another route since I knew the other routes were efficient in treating that water. Looking at the other treatments, however, it was good for the water quality treatment. Didn't do much for my phosphorus removal. However, in that impervious area, that wasn't super important for the permeable pavement, since many other parts of the project will do that. The land footprint was good for the most part. However, looking more into permeable pavement, it, in a way, kind of, to me, as my own judgment, it changed the look too much for me, and like the footprint of what would be the original, because you're not just going to lay like the asphalt or whatever down. It's going to be a different construct there. The aesthetics was nice, though. I did see some nice designs in the permeable pavement that I did like, but since that was my least important consideration, I did not end up choosing that one.
All right, thank you.
Vance, have you taken into account the distance from the entrance to the new building to the intersection? Is there enough room there to make that work?
Are we going to the transpo?
Yeah.
Yeah.
Actually, yeah, there we go. So you were saying,
I'm not sure which, the distance from the intersection to the entrance to the parking lot. Have you looked into, is that far enough to make this actually work?
I think so, based on basically what I designed in CAD. I believe it was like, what? Because in this picture, I guess it shows like, I guess it could be kind of low. That might have to be looked at a little bit more, but so far, I believe, based on what we have right now, I think it looks to be like close enough to where it's not going to cause a bunch of like wrecks or anything.
Maybe you go to the, you're actually using the signalized intersection. So we ought to look at that diagram rather than the circle.
Should I just pull the whole thing up, actually? There we go.
Yeah. So it's, you might consider moving that entrance to the parking lot to the west and enter on the side rather than in the middle, unless, again, there's no scale here. I don't know what the distance is from the entrance to the intersection. You know, if someone wants to leave and he turns right, he says, nope, I want to turn left, he's got to go across 2 lanes of traffic. And, you know, is there a backup there? That, you know, that kind of thing.
Right.
I think maybe we need to look at that a little bit.
Okay.
Any other questions? All right, thank you, everybody.